All right, hey guys. So I am going to do the lab that we would have done in person today for you to see. Hopefully you'll be able to see everything very well. I'm recording this not through Zoom, so hopefully the quality is a little bit better. So anyway, the purpose of this lab, and you should have this handout available to you if you want it online, is to combine solutions of ionic compounds. So solutions are dissolved chemicals, and name and write the formula of the resulting precipitate. So just so that we are aware, the word precipitate in chemistry means that a solid has been formed. So in this lab, we're going to see that from when we see things get cloudy or chunky. So we're looking for little tiny solid particles to form. Okay, so what we're going to do is we're going to add a whole bunch of chemicals together, and we're going to observe if we form precipitates. And then if we do, we're going to combine the ions from the compounds that make up that precipitate. So we're just practicing our formula writing and naming of compounds. All right, so I have this kind of set up in the same format here. So the whole point is to know if a precipitate forms. So if something does form, you could write down like if it gets cloudy or if it changes color or something like that. But if nothing happens, then I'm going to use NR for no reaction as my terminology. Okay, so I might write down NR for no reaction. Okay, so again, I said I have it set up like this. So this is a well plate, all right? And this has a lot more wells than what we need, but there's a little hole, a little well for each thing. And so to go along with the data table, I have the solutions across the top. Then I'm gonna put 5 drops in each of the wells down in that column. And then for the cross, the horizontal, I'm going to put 5 drops of each of these solutions in. So there will be a total of 10 drops when we're done, 5 from the vertical column compound and 5 from the horizontal solution. Okay, so the first solution we have is silver nitrate. And so silver nitrate actually will stain your hands. It is a clear solution, colorless solution. But when it gets on your hands or clothes, it stains brown. So I had to stop talking, so I added my drops. If you notice right now, you can see that it is clear and cloudy. Okay. So that is the silver nitrate. I'm going to just keep going with the vertical solutions so that we can see what all of those look like beforehand. So then we'll be able to tell if a chemical reaction happened. So the next one is the lead 2 nitrate. And this one is also clear and colorless. It's kind of hard to see something that's clear and colorless, isn't it? Right now. Okay, next one, last one in the vertical columns is calcium chloride. Calcium chloride is also clear. Okay, so everything so far, clear, colorless sort of situation. I hope we're able to see this on the white paper. If we can't, well, I can always take it off the white paper too. Okay, so the horizontal solutions. Since I have open columns, I'm going to add a drop or two next to it, which I think these are all clear solutions as well, so that might not have a big difference. Yep, it is clear in there. So now I'm going to add 5 drops across in each of my ones. Okay. So if you weren't able to see that, let me momentarily take it away from underneath there. Do you see how it's gotten like cloudy, like milk in those three? That means we've had reactions happen. So for the top row in your data table, then you could say like it got milky white, cloudy, something like that. We've had reactions for all three. Okay, so now let's go on to the next row. The next one we have is sodium phosphate. This is also clear and colorless. Hey, I see some yellow there. I don't know if you can see that or not, but I'll take it off. So I'm gonna mix up a little bit. And in all of those, we've got, it's yellow and cloudy white, cloudy white. So that means that we have had reactions in all of those too. So in the second row, where there's sodium phosphate, then they've all been reacted. I wonder if I'm gonna luck out and have reactions for everything. That just means more work for you, doesn't it? Okay, the next solution we have is sodium hydroxide, which is NaOH. This is a clear and colorless solution. Ooh, look at that. So with the silver nitrate, it turned like a brown color that time. That one's you can really definitely see. But when I take it off, then we also see white cloudy and white cloudy as well. So everything in the sodium hydroxide row right here has also reacted. Well, apparently you guys are going to look out and see reactions today. I don't think this happens when students do this themselves, so maybe they do it wrong when they're not watching a video by Miss L. Okay, the last row has sodium sulfate, another clear and colorless solution. And let's see what happened. Hey, we only have one reaction that time in the middle. So on the first and on the third, you can say NR for no reaction for the sodium sulfate row. This bottom row right here, this is a no reaction. Under the silver nitrate, this bottom row spot and this spot would also be a no reaction because we didn't see anything really happen there. Okay, so now even though it doesn't really look like a solid, right, but there is cloudiness there, and those little cloudy specks are actually little tiny precipitate solid compounds that are our precipitate that has been formed. What will happen eventually is they will all sit down and they will clump together, and then that's what makes them form the solid. So pretty cool stuff. Okay, now let's see what to do here. So you should have everything filled in, but you don't have anything here, don't have anything here. You can say NR for no reaction for those two spots. Okay, and now we're going to move on to table 2, the formula writing. So for the formula writing, what we're going to do, only for the ones that had a reaction, so not these two at the bottom, we are going to write the formula of the precipitate. So to make sure that you don't do it when you're not supposed to, do less work, put an X in that one and an X here. So we're not going to have to do anything for those bottom two spots, okay? But what we're going to do, and the cations come first. You see up here in the remember part, the cation comes first and then the anion second. So that means that the silver part will always come first, the lead will always come first, and the calcium will always come first, because those are the positives, those are the cations. Then the anions are down the side, and so that's what we're going to have come second. So for this one got white and cloudy. For the reaction between the silver nitrate and the sodium carbonate, we're going to combine the Ag plus 1 with the CO3 minus 2 and write that formula here. Okay? Because it got cloudy. So, a little refresher on how you write formulas. So we're going to combine Ag plus 1 with CO3 minus 2. Again, I got it from here and here. I put the Ag first because positive is always first. Now, when you look at the two charges, if the charges don't add to 0, we can't just put 1 and 1. And we don't have 0 here. So, the cheat way, which I taught this on the day that we talked about the flow charts, this number goes down to be the subscript on the first, the cation, and then whatever is the cation's charge number, that becomes the subscript on the second. So when you cross like that, this equals, we have 2 silver ions, and then carbonate is CO3, and we only have 1 of them. So you don't have to say the 1. Sometimes students like to put parentheses, and you can. So if you said Ag2 and then inside parentheses CO3, that's perfectly fine. They're not important. You could just say Ag2CO3 like that. That's also correct. But what's not correct is Ag2CO inside and the 3 on the outside. That is wrong. No, 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 no. Okay? So this one or this one would be the correct formula. Like that. Okay? So I'm going to pick one from every column to show you how it's done. So let's pick one from the middle column. This time, let's do a difficult one. Let's do this one right here. That it was white and cloudy as well, so you probably should have had that already. But we're going to take the Pb plus 2 with the PO4 minus 3 to write that, and that's going to come right here. So we have the Pb plus 2 with the PO4 minus 3. Okay? Now we're going to do it the same way that we did up here, where this 3 tells me I'm going to have 3 PBs, and then this 2 is going to come outside the PO4. So we're going to have PB3. Then this one we do need parentheses, and we're going to put inside the parentheses the phosphate ion, the PO4, because it has to stay together, the 1 phosphorus for every 4 oxygens, but then we said that there's a 2 on the outside. So this is the only correct way to write that formula. Okay? PB3, PO4, 2. And that goes right here. Like that. Okay, and one more from the calcium chloride column. Let's do this first one. Okay, it was white cloudy again. I'll save the exciting ones for you, for other ones. So we're going to combine the calcium, Ca plus 2, with the CO3 minus 2. Positive comes first. So Ca plus 2 and CO3 minus 2. Okay, this one, yes, you technically could cross, but since the positive charge and the negative charge, when they add together, they already equal 0, we only need 1 of each of these. This is one of my favorite kinds to write the formula of, because that means that we only need 1 calcium for every 1 carbonate. And that's the right way to write it. Or if you wanted to do the parenthesis things, because sometimes this just helps people, you could say the CO3 inside parentheses like that. But this is how I would write it myself. And that goes here. Okay? So, what I need you to do is I need you to write the formula for all of the rest of them that reacted, taking the positive first with the negative second. So if you want to, you could just like work your way down a column to fill them all in, all the way down. Okay, and then we're not turning this in on, we're not actually turning in the handout. What you're going to do is you're going to answer the questions on the It's Learning assignment. Okay, so again, you're not turning in a copy of the handout. I want you to answer some questions about this, especially since this is the first time we're doing the video lab, and so I just want some feedback on that too. Okay, please contact me if you have questions.